Okay, so the first set of angles that I just told you was angle 3 and angle 10, correct? You need to be able to identify what type of angles are those. There's corresponding, alternate interior, alternate exterior, same side interior. We need to be able to identify them. This is how I suggest that you do it. You need to make this diagram, this very complex diagram, you need to make it look like the one that we were first introduced to, the one that we colored, right? So this is how you do that. Identify where those two angles are. So here's angle 3, here's angle 10. Then block out everything that you do not need. We don't need any of this down here, correct? We don't need any of that. So literally what I do is I grab a note card, and this is what I did when I was in high school. Grab a note card, and I just cover up what I don't need. So now I'm down to only seeing 3 lines. That's good. However, we're used to the 2 lines that are generally going in the same direction. We're used to them going horizontally. And we're used to the transversal being vertical. Well, the really neat thing about paper is that it can rotate. Right? So we're gonna rotate this piece of paper 90 degrees so that my transversal is running vertical, up and down. So now I have made this complex diagram a lot more simpler, less complex, by blocking out one of the lines and also just rotating it so that it looks like the original diagram that we first learned this stuff with. So now I can see angle 3 is right here, angle 10 is right there. What type of angles are those?
Alternate exterior.
Alternate exterior angles. So that's what you need to do when we're solving. What's the second pair of angles that I told you to investigate? 6 and 15. So I'm going to put my diagram back to normal. I'm going to locate angle 6 and angle 15. So they're down here. That means I don't need any of this up top. So I'm going to put my note card and blank that out. And then I'll make it so that my transversal is running vertical. So here we go. I'm going to blank out that. Because all I need to see is angle 6 and angle 15. I'm going to rotate it 90 degrees so that my transversal is going vertical, up and down. And now I can see angle 15 and angle 6 are what type of angles?
Alternate interior.
These two guys, different sides of the transversal, alternate, and they're in between, they're interior. So those are alternate interior angles. What line is currently the transversal? P, T, N, or M?
M.
Say it louder. What line is currently the transversal?
M.
M, line M, okay? However, if I rotated it back 90 degrees and blocked the left-hand side, is line M now the transversal? No, line P is, if I'm looking at this. Line P is now the transversal when I'm comparing these two intersections. That's what I meant by that role can and will change. Can and will change. Okay, what's the third pair of angles I told you to look at? Angle 1 and angle what? 9. Angle 1 and angle 9. What are those?
Corresponding angles.
Those are corresponding. They're both in the top left position of those two intersections. And the last example that I gave you, 6 and 13, I think?
8 and 15.
Oh, 8 and 15. Okay. What are 8 and 15? What are these two angles right here?
Same side interior angles.
These are same side interior. Same side interior. Because once again, I'm going to block out everything I don't need. So all I need are the bottom two intersections. And then I'm going to rotate my piece of paper so the transversal is running up and down. And I can see that 8 and 15, those are the ones we're talking about, right? That those are in between the two lines and on the same side of the transversal. Same side interior angles. Some textbooks, some teachers, they're going to refer to those same side interior angles, they're going to refer to them as consecutive interior angles. Okay? Our Springboard textbook calls them same side interior angles. So I'm going to be consistent with that. And also I think it's a little bit easier. Same side rather than saying consecutive. So But don't freak out if you see consecutive interior angles anywhere. It's the same thing as same side interior angles. All right, are we good with identifying these different types? So we always have vertical, we always have linear pair, we're always going to have those type of angles. But now, when we're comparing two of these intersections, we've got more. Corresponding alternate interior, alternate exterior, and same side interior. At those four more. Okay? Are these lines parallel? Obviously not. Okay? These lines are obviously not parallel. Let's look at some corresponding angles real quick. Angle 2 and angle 6. Do those even remotely look like they're congruent? Same size, same shape? Not at all. Okay? Let's look at some alternate interior angles. So we've got angle 3 and angle 6. Those are alternate interior angles. Do those even look like they're close to being congruent? Not at all. That's because lines are not parallel. If we're going to, so flip to the back of this piece of paper. Now that we know these four special types of angles, when we're comparing these two different intersections, when lines are parallel that are being cut by a transversal, some interesting things start happening. And that's exactly what that sentence at the top of the page says. That when the lines that are being cut by that transversal are parallel to each other, then some interesting things start happening. And so if we look at this diagram, something that I want to point out is the parallel notation. So we have got these extra massive arrows here on these two lines N and M. That is the notation that we put in diagrams that convey those two lines are parallel. So you have these extra triangles or these extra arrows. We're going to get into some diagrams where it gets a little complex. And you're going to have multiple lines that are parallel. Multiple sets. You can have 2 lines that are parallel, you can have 3 lines that are parallel, you can have 1,700 lines that are parallel, that's fine. But in a diagram, you need to be able to differentiate between the different sets of parallel lines. So the fact that these two lines have that one triangle or arrow, that's different from these other parallel lines that have 2 triangles, 2 extra arrows like that. I tend to not write triangles. I usually do this. That's my notation for saying that those 2 lines are parallel, and for this guy I would just do 1. So be able to go back and forth with that. But if there are extra arrows or triangles on the lines, that means that those lines are parallel. Those lines are parallel. Alright, so back to your notes. Now let's look at corresponding angles. So now let's look at angle 2 and angle 6 when these lines are parallel. Now do they look like they're similar or close in size and shape? Yes, look at your alternate interior angles, so like angle 3 and angle 6. Now that lines are parallel, do those seem to be the same size, same shape? Yes, look at alternate exterior. Alternate exterior, do those look to be the same size, same shape, like angle 1 and angle 8? Yes, okay, good. We're going to learn 4 theorems today. And each one of those theorems involve one of those new special classification of angles. And they're all written on the right-hand side of your notes. They're all written as a conditional statement. They're in the if-then form. Every single one of these theorems that's written down starts off the same exact way. Starts off with, if parallel lines are cut by a transversal, they all start like that. I'm going to allow you, because that's what your textbook says, that's what a lot of textbooks say, that you have these parallel lines that are being cut by a transversal. I'm going to let you abbreviate that. And what we're going to say is, if lines parallel, we're going to use the symbol for it. If lines are parallel, then four things happen. So, then, dot, dot, dot. First off, then, well, I don't need to write it again, do I? Corresponding angles are congruent. So this is the notation that I'm going to allow you to use on proofs, on quizzes, on homework, and so on and so forth. So if lines are parallel, then corresponding angles are congruent. I'm going to let you abbreviate corresponding with C-O-R-R dot, period. Corresponding angles, and so I'm going to let you use the angle symbol with an S, and then write congruent. If lines are parallel, then corresponding angles are congruent. ALT, alternate. INT, interior. Angles are congruent. The third thing that happens, alternate. EXT, exterior. Angles are congruent. So again, what's written on the board right now is the notation or the abbreviations that I'm allowing you to use on quizzes and tests. We're not making up different abbreviations. We all need to be on the same page. So if lines are parallel, if you are told that, or if you are given that lines are parallel, then you know corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. There's also a fourth thing you know. That same side interior angles, what do your notes say? They're supplementary. So this is the different one. This is the outlier. Same side interior angles are supplementary. And I will allow you to use SUPP to abbreviate for supplementary. You need to write out the word same, write out the word side. You can abbreviate interior, use a symbol for angles, and then use SUPP for supplementary. But if you somehow prove, or if you are given that lines are parallel, then you know these four things happen with those special angle classifications that we've learned today. And you're going to be using tonight on your homework, you're going to use these theorems to help you solve for different variables and solve for missing angle measurements and so on and so forth. Okay, so this is 4 different theorems. This is 4 complete, different, separate, if-then statements. So I'm going to go ahead and erase this. But I'm going to keep one